Hello everyone. In this short video I wanted to go over how to calculate out the tension in a string for an object that is in static equilibrium. So here I have a block that's supported by 3 strings, and the question asks, what is the tension in each string? In this problem I'm going to use to the right is positive and up is positive, and the first thing I'm going to do is draw out a free body diagram. So here I have a rough sketch of the forces acting on this object. I'm going to use the fact that I know that it's in static equilibrium, so the net force must sum to 0. In other words, all my ups and downs, all my lefts and rights, when I'm done adding them up, they must add up to 0. So I like to make a little chart just to keep track of everything, kind of like what I've drawn here. Now I'm just going to start filling in the chart, keeping in mind that the result at the end is all going to add up to 0. So here's the chart filled in. As you can see, T1 is all the tension is to the left, hence the negative that's there. And there's nothing in the vertical, so it's all going to the left. T2 has some to the right, and then it also has some up and down as well. So using this 40-degree angle, I can plug that in a little bit later. And then for 3, which is this string right there, there's nothing in the x component. All of the force would be directed in the y, and I'm going to use the fact that it's a 2 kilogram mass to help me out with the figuring out what that force happens to be. So now I just sum up all of my x components and set them equal to 0, and then I sum up all the y components and set them equal to 0. The easiest of the tensions to solve for is T3, as we know what the mass of the block is, and we know what gravity is. Plugging in the values of 2 kilograms and negative 9.8 meters per second squared, we get 19.6 newtons. But don't forget, it is negative because it's in the downward direction. Here we have the x and the y components. We're going to use these to solve for T1 and T2. We've already solved for negative mg, so we can plug that in. And we also know what the angle is. It was 40 degrees, so we can plug that in. Sine of 40 is a number, and we have 19.6 newtons, 0. The only thing we don't know in this equation is T2, so we just move everything over to the right-hand side, except for T2. So the tension in rope 2 ends up being 30.5 newtons. We're going to use this to help us solve for T1. So now I've taken the x components, plugged in the values that I know, and I've solved for T1, which is 23.4 newtons. But don't forget, it is pointed to the left, so it's got to be a negative value. So if we go back to our original drawing and label the free body diagram that we have, this is what it would look like. I hope this video helped, and thank you very much for watching.